Okay, so welcome to day 7 of month 2. So today we are going to be looking at different types of algorithms and understanding what an algorithm is, right? Right. So I want you guys to understand something very important, right? There is not one algorithm that solves every programming problem. Different problems require different approaches, right? So an algorithm is simply a set of steps used to solve a problem. Right? Algorithm, right, is simply a set of steps, right, used to solve a problem. So this is what an algorithm is, right? Right. For example, if I want to find a student's name in a list, I need what? A search algorithm, right? If I want to arrange our students alphabetically, I need a sorting algorithm, right? So there are different types of algorithms, right? And an algorithm is simply a set of steps used to solve a problem, right? So here are the common types of what algorithms that are available, right? Common types of algorithms, right? One, we can have what search algorithm, right? We can have what a sorting algorithm. We have what you call traversal algorithms, right? We have graph algorithms, right? We have divide and conquer algorithms, right? We also have what backtracking algorithms, right? So these are some of the what are the common the common types of algorithms that are there, right? So you can never finish all of the algorithms. You can never finish them, right? So you do not need to master all of these algorithms, right? So what you just need to know is that an algorithm is just as simply is simply a set of steps used to solve a problem, right? And you should know, you should understand what kinds of problems each algorithm solves, right? So within these, for example, these algorithms like search algorithm, there are also different types of algorithms that fall under what the search algorithm. Same goes for sorting algorithms. There are also algorithms that fall under what sorting algorithms, right? So a search algorithm just it's for searching items. A sorting algorithm is what? It's for sorting items. Right. So we also have what traversal algorithms, right? So a traversal algorithm means visiting items in a data structure. Right. So a traversal algorithms means visiting items in what? In a data structure. Right. And graph algorithms, they work, okay, let me just say for traversal it means what? Visiting items in a data structure, right? And the graph algorithm that work with relationships, work with relation okay, work with relationships between connected things, right? Then also you have divide and conquer. So a divide and conquer algorithm, right, it breaks a large problem into smaller problems, right? So instead of solving one large problem, we can just break it into smaller pieces and solve each piece one by one, right? And then we have what are backtracking, right? This one it just what tries a possible solution. So it's not the correct solution, it just tries what a possible solution, right? So if that choice leads to a dead end, the algorithm goes back and tries another option, right? So this type of algorithm is useful for problems such as puzzles and certain combination of choices, right? So for this lesson, I want us to focus on one search algorithm, right? So search algorithm just means finding something inside a collection of data, right? So a search algorithm just means finding something inside a collection of data, right? For example, let's say we have what a list with students, right? Let's say we have Brandon, we have Tadiwa, we have Nyasha, and we have Mofaro, right? If I ask Python to find Tadiwa, Python needs some strategy, right? That strategy is called what? The searching algorithm, because it's going to search through this list and find what? Tadiwa, right? So within our search algorithms, right, there are many searching algorithms. You can never finish them, right? So for now, I want us to focus on what? On two algorithms. The most common searching algorithms is what? Linear search and binary search, right? So it's linear search and binary search, right? So these are the two common what? Types of searching algorithms, right? So linear search, okay, let me say, okay, right? So linear search, right, it checks one item at a time. Checks out one item at a time, right? And then binary search, it searches, right? And binary search uses what? A different strategy compared to linear search. It requires the data to be sorted, right? So it requires what? The data to be sorted, right? So linear search doesn't require the data to be sorted. It works with that data structure as it is. But with a binary search, you need to first sort your data structure, right? So now, and also with a binary search, right, instead of checking every item one at a time, right, binary search looks at the middle, right? It looks at the middle, right? For example, let's say ages equals to 18, 25, 30, 22, and 27, right? So instead of searching every item one at a time, right, the binary search looks at the middle. In this case, it can be what? It can be 30, right? So it then decides, right, whether the target must be on the left or on the right, right? So when it gets the middle value, remember that with binary search, this is going to be ordered, right? So when it's now ordered, it gets the middle value, right? Then it decides whether the target must be on the left or on the right, right? So it then eliminates half of the remaining search area, right? So which means it's going to first search the right side or the left side. When it's done with that side, then it moves over to the other side that it didn't search before. So it repeats that process until it finds the target or determines that the target does not exist, right? So okay, let's say, right, with the linear search, right, see, it checks, right, one by one, right? It works on unsorted data, right? So it can require checking, right, many items, right? And then binary search, right? Binary search, it checks the middle, right? And then it requires what sorted data, right? And it eliminates, right? Eliminates what, half of the search area, right? So these are the two most common search algorithms, right? So I want us to look at linear search, right? So linear search, right? So I want us to have a student's list, right? Let's say we have Brandon, John, Anyasha, and Mufaro, right? So with this list, I want to find, let's say, Nyasha, right? So one simple approach is to check each name one by one. Start with Brandon, move to John, then move to Nyasha, right? So which means it's going to Python is going to check, right? Is Brandon equals to Nyasha? No. Then it cancels it out, moves over to John. Then it asks, is John equals to Nyasha? Then no, it cancels John out, then moves over to To Nyasha now. Is Nyasha equals to Nyasha? Then the answer is what? Is yes. So this is what linear search. We move through the collection from one end to another, from left to right. Right? So a basic example of linear search can be, let's say, target equals to Nyasha, right? Right. So let's say for student in students, right? If student is equal to target, right? Print, let's just say print student found, right? Then break to end our loop, right? So this students list, this is our collection, right? This is our collection, this is our data source, right? And target is the what? Is the student that you are looking for, right? So here we have what? A for loop for student in students, right? So this for loop takes each student one by one, right? One at a time, right? So then we have what? If student equals to target, right? The if statement checks whether the current student is the student that we want. If it is, then we print what student found, then we end the loop, right? So there's no reason to continue searching after we've already found the student, right? uh any questions about line 28 up to line 36? Any questions? Yes, Mr. Changa.
Yeah, what exactly we were learning about, to say maybe when you, for example, when we created the student management system, we actually utilized or demonstrated the linear search in a manner. I remember we used to, for example, when we used to search for a student in our JSON file, we used that. For example, we used a similar syntax to the one you wrote from line 29 going downwards. So this is now more of just describing, is it? I don't know, but I hope my question is clear.
Yes, your question is clear. Yes. So now you can see that you have been using algorithms before. You just didn't know that you are actually this is what is an algorithm.
Okay, I'm answered.
You answer. Okay. So whenever you create a function that does something, you're actually creating an algorithm, right? You just need to know what type of algorithm it is, whether it's a linear search, it's a binary search, or it's a traversal sorting or whatever, right? So let's say I'm now running the code, right? I ran the code and it's printed what student found, right? Because we found that student, right? So let's change our target. Let's say our target is Tadiwa, right? I'm now running the code again. See, nothing was printed. Tadiwa is not in our list, right? So the loops check throughout the list. It reaches the end without finding what Tadiwa, right? So the code works, but there's a problem, right? So what if we do have Tadiwa, right? But it's not in this list. It's in a different list, right? So we have what many different lists. So we don't want to rewrite the same search code every time, right? So we can actually put our algorithm inside what? Inside a function, right? So to make it reusable, we can put our algorithm inside what? A function, right? So let me see. Right. So let's say, right, we have what? We create a function called what? linear search, right? It says what items target, right? Then for item in items, right? But if item is equal to our target, right, return true. Right. Otherwise, just return false, just to say that we didn't find our item, right? So let me copy what this list, edit down here. Okay. So let's say result equals to linear search what students, and our target is going to be what, let's say John, right? Then print result, right? So this is actually is the same as this. The difference is that now it's now inside the function. We can now reuse it anywhere, wherever we want to search through something, right? But if you notice that instead of printing, right, we are now using what, return what, true, right? So meaning that when Python finds the target, it immediately returns what, true, right? So returning from a function also stops the function completely. So there's no need for the break keyword, right? So if this loop, right, it finishes without finding the target, we just return what, return false, right? So if it finds the target, it returns true, and if it doesn't find the target, it returns what, it returns false, right? So okay, so I've saved the code. I'm not running the code. Our target is what, is John, right? I'm not running the code. See, it returned true. So since you know somewhere in your code you would have configured it, if it returns true, you're supposed to do 1 2 3, right? If it returns false, it's supposed to do this and that, right? So these two is just the same thing, but the difference is that this function is reusable. This second linear search algorithm is what, it's reusable, right? So sometimes, right, we don't want to know whether the item exists or it doesn't exist. We don't want to know whether the item exists, right? We just want to know where it is, right? By knowing where it is, that means we want to know the index. We want to know its position, right? So let me comment this out, right? It says create another linear search function, right? So we can use that items target, right? Let's say for index in range, okay, length items, right? If items index, okay, equals to target, right? Return index, right? Else it should return what? -1, right? Let me copy this. So it's students equals to Brandon John Nyasha and Mofaro, right? And the result equals to linear search, right? Students, let's say we want okay, let's say Nyasha, right? And then we print the result. Right. Right. So remember that Brandon is at index what? At index 0. John is at what? Index 1. Nyasha index 2. And Mufaro is at index 3. Right. So therefore, what our target Nyasha is at index what? Index number 2. Right. So here we have what? Return -1. Right. So we return -1 so that in case when our target, right, is a name that doesn't exist in our data structure, in our data, right, we should just return what? -1, right? So you can prompt it to return anything that you want, but usually we use that -1 to show that the index that you are looking for, it doesn't exist, the value doesn't exist, so it is not what? Found, right? So this is a linear search algorithm that just takes what? The index of a specific value and returns what? The index, right? So we use remember that we use the len function what? To get how many items are inside what? That list, right? If there are 5 items, we're going to know there are 5 items. There are 100 items, we're going to know there are 100 items. Right. So, any questions so far? Yes.
Yeah, Mr. Kumar, if time allows, I don't know if you could just re-explain those two functions that we created, the other one on line 49 and the other one that we created, the one which you commented out. Those two, yeah, I'm having a bit of a challenge.
Which one?
From line 38 up to the current line.
So this line 38, right? It's just a function that takes what 2 parameters, right? It takes
two parameters. By
Yes.
that time, it doesn't know if it's a list. It is just taking two parameters.
Yes, it doesn't know whether it's a list, it's whatever.
Okay.
So it just takes items and target, right? So then here in our for loop, we'll just say for item, not in items. You you as the person writing the code, you know that items what is going to be a list.
The list.
Yes. So that's why I can easily loop for item in items, right? If item is equal to the target, return true. In this case, our target is what? If you look at line 46, it's going to be what? Is going to be John. Right? So you are passing John as an argument. So here Python is not seeing target, it's seeing what? It's seeing John, this string John. This is what it is seeing, right? And then here we're also passing what? Students as what? As an argument. So we're passing this list that is on line 45. We're passing it as an argument. So it's the one that we're going to loop over here in items.
Okay.
Right. Remember that the parameter here, the names are going to they can be the same or they cannot be the same. Like if you see on line 38 we have items target, but on line 46 we have what? Students and John. It's two different names, but Python knows that we can here the first value, it's what is belongs to items, and the second value belongs to target. Right.
Yeah, I understand.
Right. And then with this second function, we're just getting what? The indexes. We're still passing what? Our list and what? And our target. Right? Then we're still going to loop over that list using what? The range and len functions to know how many values are inside what? Inside our list. To know if we have what? 2 values, 3 values, 4 values. Right. So here are just so with this index we're not accessing what? We're not accessing the values directly. We're accessing their indexes, their positioning. So this index, it doesn't know whether it's Brandon, it's John, it's Nyasha, or it's Mofaro. It just knows 0, 1, 2, 3.
Position.
Right. And then on line 51, if items, right, square bracket index. So what's it doing here? It's now using what? The dictionary format to check if in our list items, right, and this index, right, on line 50, okay, it will check, okay,
It's equal to the target.
yes, if okay, the items that are index 0, or it's Brandon, is it equal to the target? No, it's not. Okay, we're moving to the next item. So it's John. Okay, it's index what? Index number 1. Is it equal to the target? No, it's not. Okay, we're moving to Nyasha. Okay, Nyasha is at index number 2. Is it equal to the target? Yes, it is. Let's only return the target. Let's not return what? Let's not return the value, just the index, right? And then with this return -1, if our target is not inside the list, we just return -1 just to say that we didn't find what? The target. This is what is happening.
Okay.
Right. So do you now get it?
Yeah, I do. I do.
Okay, then that way. So do you guys remember the time complexities are big connotation that we talked about yesterday?
Sorry?
The big notation, the one that we talked about yesterday. Okay. So from the complexities that we talked about, which one do you think linear search belongs to? Which one do you guys
Okay,
think?
can you just let me just give us maybe some 15 seconds to.
Okay, that's fine. Yes.
Uh, I just guess because since the number of inputs of the students may increase, I'm thinking ON, O then bracket N.
That's
That's my
correct.
guess.
Oh, yes, yeah, correct. So that's because that if we have 1,000 names, the odds are it might check all those 1,000 names. If we have 1 million names, the odds are it might check all those 1,000 names. So that is why what a linear search is 0n. Right. So now the advantage with linear search that it has what a best case, an average case, and a worst case, right? So the best case is that the item is at the beginning of the list, right? And the average case is that the item is at the middle of the list, and the worst case is that the item is at the end of the list, right? So meaning that with the worst case, it's going to what search everything, and with the best case, the moment it starts searching, it finds what that item. So it can have either three of those cases, right? So any questions with linear search or with algorithms? Any questions? Okay, so I'll take that as no questions, and that everyone understood what are algorithms and how they work, right? So the best thing that you guys can do is since we talked about the searching algorithms, right? And is you can try and implement a binary search on your own. Create your own list with random values and try to search within that list on your own and create your own what binary search algorithm. Okay. So if there are no any questions, then that's it for today, and I'll see you guys tomorrow. Yes. No, we didn't.
I didn't, yes.
Yes, we only looked at the linear search.
Okay.
Okay.
So are we going to learn about that, or you want us to learn on that entire on our own, or you're going to discuss about that?
No, this one we're not going to discuss about it, the binary search. I want you guys to try
Okay.
and do it on your own. Remember that
Okay.
the thing with coding is that most of the things you are going to have to learn on your own. You need to do your own research and figure out how to solve a particular problem. So I want you guys to try and do this one on your own, binary search. Or if you want a bigger problem, you can try and do a sorting algorithm.
It's okay. Mr. Dukes was raising a hand.
Okay, yes, Mr. Tubes.
Oh yeah, sorry. When you started, you said okay. So these six are the most common types. How many algorithms did you say there are? Are they like plenty, or maybe hundreds? Or just an estimate number.
There are a lot of algorithms, millions and millions of algorithms.
Really? Okay.
Because, for example, like let's take a look at WhatsApp. WhatsApp on its own, there are some algorithms that we don't even know about them. and they used a lot of algorithms. So we don't have the specific number of algorithms that exist out there.
No, but you can create on your own an algorithm using like what you just did with the function and everything, right?
Yes, yes, you can create your own algorithm.
Can you?
Yes, you can.
Okay, okay. I get that.
For
Yeah.
example, like things like Facebook or TikTok, the feed that you see, there's an algorithm behind their own custom-made algorithm. So you can actually create your own algorithm.
Okay. Okay. So what is the difference between uh, coding to create a website and creating an algorithm? Is it almost the same or is it two different things altogether? Like when you are speaking on a technical term, like what do you say? Like I created a website or I created an algorithm,
No, you say you created the website. So
the
usually,
website.
yes, because usually algorithms are things that the users can see at the brains of a system. What the users
Okay.
see, it's not an algorithm. We
It's
are,
an end product.
yes, so you are going to get to understand more what's the difference between algorithms, backend, front end, when you start learning about backend programming.
Okay,
Yeah.
okay,
So you're
okay.
going to see the difference between those two.
All right. I understand. Thank you so much.
Okay, great.
When is backend programming, by the way?
Was I think let me check. I think we're supposed to have an introduction next week. Let me check. Oh yes, Monday. Monday we're going to be looking at backend programming.
It's okay, thank you.
Okay. Yeah, so Monday we're starting a new chapter, backend programming, next week. That's when you're going to have an idea of how systems are actually built, what actually happens behind a website or TikTok or WhatsApp or anything. Alright. So, any questions? Okay. If there are no any questions, then that's it for today, and I'll see you guys tomorrow. Right. Cheers. Take care.